Hello and welcome back to the channel. Hey, I'm Ron with Ideal Industries and welcome to my shop. And in this segment we're going to talk about testers and meters, not datacom stuff. And I'm going to cover the Ideal basic testers and meters and digital multimeters we have, which we call our Resi Pro line, which is kind of our introductory level of testers. And if you're looking for test equipment that is much more accurate or does more things, please check out the Ideal website. You'll find that we have testers to cover a lot of applications out there. And when I look at this group of testers, these are testers that just about anybody can afford. I mean, they start in the $20-some range and go up from there. But they're great little meters that most of us could use for working around the house, so they're great for the remodeler or the homeowner, and also for that entry-level pro kind of person that's looking for their first kind of meters that they might be wanting to buy out in the industry. So these are great products, and the first one we'll start here with in this segment is dedicated to the 61-310 tester. And we're going to show you a close-up of that, and I'm going to walk you around the dial. Here's a close-up view of the 61-310, and you can get a good look at the face of the tester. And of course, there's the part number on the tester right there. And of course, we have some openings in here to put the test leads. We have obviously a dial that tells us a bunch of stuff around it, and I'll show you what all this means. There's a hold button if you want to take a reading and hold it, and of course, then obviously a display up top. Now, when I look at the tester, one of the things I'm going to show you on the tester right there, it says Cat 2. And you need to understand something about where these testers are designed to be used. And a Category 2 tester tells me it's a tester that is designed to be used and safe to use inside of a home through, basically branch circuits. So if I'm testing electrical lines in the house or lighting lines or appliances, the tester is designed for that. It also could do low voltage applications as well. We're a Class 1 tester designed for low voltage applications only, telecommunications circuits, things like that. Of course, Class 3 gets us up into the electrical breaker panels, and then Class 4 beyond that. But so this is a tester that's great for what we're going to do inside of a home. Now, one of the first things we need to do is put some leads in it, and you get some test leads, and the black lead always goes into the one that says common. The red one can go actually either on either side, depending on what you're trying to measure. Now, right above this one here, it says 10A, indicating 10 amps, and it's DC amperage. The tester does not do AC amperage, and if I'm going to measure up to 10 amps, I need to be in that opening with my red lead. Over here, you'll see temp. You'll see a V for voltage, an omega symbol for resistance, and of course a little m and big A, which means milliamps of current. So in most cases, it's going to be over here in the red one. On the one on the right. Okay, so it should look like that when we get ready to do most of your testing. Now, the first thing we might do when we do a test is check to make sure the meter's working. And you'll see a symbol right here, which is a diode setting. And right next to it is kind of an audible setting. I'm going to take the tester and set it into that audible setting. And you'll see up top here, the testers, this is showing me an open is what that is indicating to me by the tester. So in other words, the tester is seeing an open circuit and can't measure it. It's too big of a resistance to measure. Now, these testers, if I take the test leads and touch them together, the tester should go to 0, and it's making an audible sound that I'll hear, indicating that it sees continuity. And I really don't even have to be looking at the tester. I'll be looking for the audible sound. Okay, and that's what that's for. And this tells me the tester is working, and it's safe to use now, and make some measurements. And then one of the first things you're always taught is make sure the tester's working, because it could be the test leads or the tester itself is not working. Okay, now. Let's test this at the top here. It is off now. And then when you look at some things we can measure with the tester, and one of the things I guess we should measure is maybe that diode setting, since we had it on that diode setting. And if I'm going to test a diode, again, the tester's showing me an open here. A diode is a device that only lets current flow through it really in one direction only. And that little black deal there on that board is a diode. So if I take my two test leads and I touch them across the diode, and I get no reading at all in the tester, that's telling me that the diode won't let any current flow through it in that direction. Now, if I reverse the test leads and get them opposite, now it's giving me a reading and showing me about a half an ohm here. And that's indicating the tester that diode is working, because it is giving a reading at least one of the two directions. So a diode's good if it gives you a reading in one of the two directions. Okay. Now let's turn that back to off, and maybe now let's take a look at the DC stuff here. Now over here you see DC voltage, and we see 20, 200, and 600 volts. This will measure up to 600 volts DC, either AC or DC. You also see over here for battery, and it says 1.5 volts for those, AA and AAA batteries, and of course there's a 9-volt battery setting there too. So if I'm going to measure DC, which is as simple as a 9-volt battery, but I'm going to use one of these settings over here to see the difference in these different settings here. Now, in order to measure DC voltage properly, we have to set the tester at the next highest setting we are suspecting that we're going to measure. So a 9-volt battery should be someplace between 2 and 20 volts. Okay, and if we take a look at a 9-volt battery over here and take our test leads, and the bigger of the two spots on that battery is the negative lead, and I push the positive lead here, I get 9.63 volt DC volts here being measured, and which is kind of what I would expect. And if I flip the leads accidentally and get them backwards on the positive or the negative on the positive, and the tester gives me now a negative reading, and indicating I might have my leads backwards. Now, if I took the tester and set it into 2 and make a test now, the tester is going to give me that overload indication with that 1 on the far left over like there, and that is not good. So obviously we're measuring something above it, so we want to be above 20. Now on the opposite side, if I had it at 600 and I make this same test, again it's above 9 volts, so it's going to give me a reading, but it's not quite as accurate. It's not 9 point something, it's rounded up to 9. So depending on what setting you have it here will change the accuracy you have in your meter. And if you want an auto ranging tester, you can buy those, and we don't have to worry about what setting it's just in voltage. Okay. All right, now I'm going to turn that off, and that's a basic DC voltage that we could measure in the home or around the house. Now, if I want to measure some AC stuff, I can take an electrical outlet plug here, and the tester has 2 settings for AC over here, AC voltage. We've got 200 and 600. And obviously, in most cases, we're going to be at 200 volts if you're working with 120 volt circuits inside the homes. And if I take the tester and just set the leads into the outlet there, it's going to give me a reading, and that's pretty close to 120 volts there. By the way, if you want to take that tester, again, it's reading 120 volts, and if I moved it to 600, it's going to give me another reading, but again, the accuracy is not quite what it was. I lost the decimal points there. Okay, and if you want to actually hold the reading, and for instance, I can't read the meter, and I want to hold it into here, then I just hit the hold button. You'll see the hold button kind of came on over there, and when I take the leads out of the electrical outlet, it's still going to give me the reading that we were looking for. Okay, so that's the hold function. And again, if I push it one more time, it's going to take it away, and it's completely gone away. Okay, and so that's basic AC measurements with the tester. Again, I'll turn it back off. We can obviously measure some resistance with the meter, so we have ohms over here. And when I look at the ohm settings, we got 200, 2K, which means 2,000, 20K means 20,000, 200,000 ohms, and the 20 with the big M means mega ohms, or millions of ohms. Okay, well, anything above that indicates an open to the tester. Now, if I'm going to measure resistance in something, we can measure resistance in a lot of things, between the resistance in a wire, or checking a fuse, or a switch, or something like that for continuity. And I have some little resistors on this little board as well over here. And right now we have it in 200, and the tester's indicating open because we haven't got the test leads across to anything. And I see 2 little resistors here. And if I took the test leads across one of the resistors, whoops, it gives me a reading, and it's about 180 ohms is what it's indicating there. Now, which is, and if I could read the little stripes on the resistor, it would indicate that's what it's supposed to be. Now, the 2 resistors here are actually tied together. It comes in here, comes to this connection, and through the printed circuit board, it ties into this resistor to that point, and comes here. So these 2 resistors are in series. And if I take my test lead and touch it to the other end there, you saw a quick reading. And then the tester went to overload reading. And the reason is because these are both 108 ohm resistors, so 2 of them together in series should be around 360, but I've got it in the 200 setting here. So what I need to do is move that setting to 2K. That means 2,000 ohms, and now when I take a new reading here with the tester, it's going to give me a reading. It says 0.358. Okay. Now, since we're in the K setting or thousands, we need to take this decimal point. We're measuring 358 thousandths or 350 thousandths of a volt. So what it basically means is we got to move the decimal point 3 points to the right. So it actually is reading 358 ohms, I should say, not volts, ohms. Okay, and we take the tester, it goes off again. So again, if I have it in a higher setting over here, maybe I'll move this to 200K and take that same reading with the tester. Again, my accuracy is not going to be as good as it used to be. Now it says 0.2. And since we're in 200K, we'd have to move this decimal point again 3 decimal points to the right, indicating 200 ohms. Okay, so again, it's not quite as accurate because, again, we may not have it in the right setting here. You always want to go at the next highest setting you suspect you're going to be measuring. And again, we'll take that and turn that back to off here. Now, and by the way, when I measure resistance, some other things I should point out too. So let's put it back down to 200 here. And we want to measure the resistance across, say, this little switch here. If I want to do that, I can. Again, I put it at 200 ohms, and I take my 2 test leads and I put it across the switch. And it basically goes 20 on me there. That's indicating the switch is good and it's got a circuit. Now, if I turn the switch off, it should give me virtually no reading at all, which again is indicating an open there. Okay? And again, if the switch is closed, the tester should go back down to 0 there, indicating that, again, the switch is working properly. Okay? If we wanted to check, say, the resistance across, or see if this cord is working here, the test leads, you can buy little boots, alligator boots, that will insert over the test leads themselves and turn those into little alligator clips. Okay, and if I clip them across, again, my component video cable here, and take a measurement here, and now the tester is going down to looks about 2 ohms there, 0.2 ohms, so a pretty small resistance, but again, not quite 0, but I want to see something there, so it's indicating their continuity across that wire that we want to measure. And even if we wanted to go back here and measure, say, a fuse, we could take a fuse here that we want to measure, and again, take the test leads and go across it, and take a reading with this, and it's showing me about, well, pretty close to 5 ohms across that little fuse. So the fuse is working. So there's a lot of reasons why we might actually use that resistance setting on the tester to measure a number of things as we're troubleshooting circuits. So here I'm going to turn this all back off again. And one of the things we can measure with the tester is current. So I'm going to bring my little board back in, and I'm going to put my battery in my little board here, and the battery has a little potentiometer over here that will allow me to vary the amount of current flowing through this printed circuit board. And there's some test leads right here that I'm going to attach the tester to. Now, when you're measuring current in a circuit, DC currents here, and I'm going to turn the tester to DC, and I'm going to go to 200 milliamps here. You got to understand the tester needs to be part of the circuit. So the current actually has to flow through the meter. And one of the reasons these testers don't read high amounts of amperages basically is because it's really not safe, because the amperage has to flow. Could you imagine 200 amps in a circuit panel flowing through this? It's actually not safe. You want to use clamp meters for those applications. But for little DC, little printed circuit boards things, these testers work great. So what I'm going to do is I'm going to attach the other test lead to the other lead on the bottom here, and that lights up my little light here on my board, and it's indicating I'm pulling about 6 milliohms of current, because again I'm at the 200 milliamp setting, so it's somewhere under milliamps, 6 milliamps. Okay. Now if I turn my knob, my light gets a little brighter, and my current flow goes up. And if I turn it all the way up, the light gets pretty bright, and we're pulling pretty much 20 milliamps of current here at this point. And if I turn it back down, the amperage here will go down as well. And again, the light gets a little dimmer as we do that. Okay? So here again, the current is actually flowing through the tester itself. And a word of warning, if you have the tester in this setting and you happen to hit voltage, AC or DC with it, we're going to fry the little fuse inside the tester, which is not a bad thing necessarily. You'll just have to replace the fuse. And I'll show you a little later how you would go about doing that. All right, so now we're going to just turn this off. Or if I left it on and just removed one of these leads, the light would go out and the tester goes to 0. Okay. Now, I'm going to take that, set that aside, and I'm going to take this and set aside, and I'm going to take these leads out of the tester and show you one other function that you have with this tester, and that is temperature. Now, the tester will come with a thermocouple. And when you look at the thermocouple, you'll see a negative and a positive on that thermocouple on this portion that plugs into the tester. And you'll notice that these kind of line up with those two openings there. And we wouldn't want to plug it into these two. We want to plug it into these two with the negative one over here plugging into the common one. So we're just going to insert that in there like that. And the very tip of this little is our sensor itself that is actually going to measure the temperature. So now I'm taking a tester, I put it in Fahrenheit, and the tester is reading somewhere around 69 or 70 degrees for me. Okay, and the tester may take a few seconds to settle on the temperature, but it will eventually settle down. And of course, if I put my hand on the tip of this, it should actually go up quite a bit too. So again, that's how we go about measuring temperature with these little thermocouples. And if you happen to get a thermocouple that wasn't calibrated with the tester, it may not be quite as accurate. You can calibrate these to with a known thermometer, or there are ways of adjusting the accuracy on the temperature inside the meter. And you can look for Ideal's website on how to actually do that. And that's and again, we could do it in Celsius as well. All right, and there's your basic temperature connections we would work with a tester. Now the tester has a rubber boot on it, and if we need to, for whatever reason, change out the batteries or work on something in the tester, we can take that rubber boot off. The testers have these little stands that allow the tester to stand up if you need it to stand up and look at it. And then we see some pocket back here that we can grab these two screws out of. And drop that off. And there's our battery that comes out the back of it. Okay. And occasionally you might have to replace the 9-volt battery. Obviously the tester doesn't come on when you turn the knob on. It could be just the battery is dead in it. And then also, if you look at the two screws here inside of this, if I want to get inside the tester because I've blown the fuse, or I want to maybe make that adjustment on the temperature probes, I would remove those two screws. That would open up the case itself, and you will find something holding your little fuse that you would have to replace, and just pop that fuse out and put a new one in. If it's no longer measuring DC amps, that's what you're going to have to do. And there's some varistors in there that we can make some adjustments on the temperature as well. So there you go. That is the 61-310, and it's a great basic digital multimeter. Again, used for around the home, do those projects for lighting and electrical circuits and appliances. So thanks again for coming to another segment of terminating low voltage cables, but in this case we did some tester meter stuff. Again, I'm Ron with Ideal Industries, and thanks for coming.